Forultimate Bliss School. You're welcome to our online class. Lesson 1, Chemistry. Topic is formula mass, and our facilitator for this online class is Mr. Henry Okorie. At the end of the lesson, students should be able to 1. Define formula mass. 2. Calculate formula mass. 3. Calculate percentage composition by mass. We are going to see how we can achieve these 3 objectives, the objectives of this lesson. Formula mass. What is formula mass? Formula mass of a molecule is the sum of the average atomic masses of each atom, represented in the chemical formula of the compound. The formula mass is calculated by adding up all the atomic masses for every atom in the formula. Formula mass is also regarded as relative molecular mass, and it could either be relative atomic mass or relative molecular mass. Relative atomic mass if it involves an element or an atom. Then relative molecular mass if it involves a compound. So when you calculate the sum of the individual relative atomic masses of each atom in that compound, the sum will give you the relative molecular mass, also regarded as formula mass of the compound. So formula mass. Now, calculations involving formula mass. Example 1. Calculate the formula mass of trilead tetraoxide. And trilead tetraoxide is Pb3O4. Pb has a relative atomic mass of 207, and oxygen has a relative atomic mass of 16. How do you solve this problem? First of all, you need to consider each element for each atom. In this element, we have lead, and this lead has 3 atoms. We have 3 atoms of lead. In oxygen has 4 atoms. We have 4 atoms of oxygen. So you have to consider the atoms, because you multiply the atoms by the relative atomic mass of that element or compound. So since we have 3 atoms here, we have 3 times the relative atomic mass of lead, which is 207, plus 4 times the relative atomic mass of oxygen, which is 16. When you multiply 3 times 207, you have 621 rather, plus 4 times 16, you have 64. If you sum it up together, you're going to have 685. This 685 is the formula mass, or otherwise regarded as the relative molecular mass of trilead tetraoxide, Pb3O4. Example 2. Calculate the formula mass of CaNO3 bracket 2, that's calcium trioxonitrate 5. Calcium has relative atomic mass of 40, nitrogen 40, oxygen 16. Solution to this problem. Your Ca, which is calcium, has just 1 atom. So we have 1 atom of calcium. Why is nitrogen being affected by these 2 outside the bracket or outside the parentheses? So invisible 1 for nitrogen times these 2, that will make it 2. So we have 2 atoms of nitrogen. For oxygen, we have 3 atoms of oxygen inside the bracket, then times the 2 outside, that will make it what? 6 atoms of oxygen. So to solve this problem, you see the 1 atom of calcium times the relative atomic mass of calcium, which is 40, plus the 2 atoms of nitrogen times relative atomic mass of nitrogen, which is 14, plus 6 atoms of oxygen times the relative atomic mass of oxygen, which is 60. And that will give us 1 times 40 is 40, 2 times 14 is 28, and 6 times 60 is 96. If you sum it all together, you're going to have 164 as your relative atomic mass, relative molecular mass rather, or otherwise regarded as your formula mass. Percentage composition by mass. To calculate the percentage composition by mass, we are going to be applying our formula mass method. Then also we'll now calculate the percentage of each element in that compound. For example, calculate the percentage by mass of each element in calcium hydroxide. And calcium hydroxide is CaOH in bracket 2. Calcium has relative atomic mass of 40. Oxygen has relative atomic mass of 16. Hydrogen has relative atomic mass of 1. So to solve this problem, if you look at the compound calcium hydroxide, your calcium has 1 atom, so Ca. Your oxygen are affected by the 2 outside, so you have 2 atoms of oxygen. Your hydrogen is being affected by the 2 outside, so you have 2 atoms of hydrogen. So for calcium, since you have 1 atom of calcium, so 1 times 40 will give you 40. Then 2 times 16, then you have 2 times 1. So it's 40 plus 32 plus 2, and that will give us what? 74. So what we have just done is the formula mass, or otherwise known as the relative molecular mass of calcium hydroxide. The next step is to calculate the percentage by mass of each element in the compound. Don't forget we have 3 elements in that compound: calcium, oxygen, and hydrogen. So percentage by mass of calcium will be equal to the relative atomic mass of calcium in the compound is 40. It's 40. So say 40 divided by 70, which is the total relative atomic mass, that's the relative molecular mass of calcium hydroxide, that's 70 times 100%. If you calculate this, you're going to have 54.1%. Percentage by mass of oxygen. Oxygen, based on the compound, oxygen has 2 atoms, so it is 32. That's 32. So we have 32 divided by 70, which is the relative molecular mass of the entire compound, times 100%. That will give us 43.2%. Percentage by mass of hydrogen. Hydrogen has 2 atoms in the compound. So 2 divided by 70 times 100%, and that will give us 2.7%. Alternatively, if you have gotten your percentage by mass of calcium and that of oxygen, you can easily get that of hydrogen using an alternative method. And to do that, what you need to do is, the total compound generally is regarded as has a percentage of 100, so 100%. So it's 100% minus the percentage of calcium plus the percentage of oxygen. If you add these two together, you're going to get a value. Then if you say 100 minus that value, you will get 42.7%. Precisely, you're going to get, if you say that's 100 minus 54.1 plus 43.2, that will give us 97.3. So 97.3. If you minus 100 from 97.3, you're going to have 2.7%. Feel free. It's time for questions. If you have any question, ask question and answer. If you have any question, can ask a question. Class activity. I would like you to do this briefly to test your knowledge. First, number 1, calculate the percentage by mass of all the component elements in sodium tetraoxosulfate 6. calculate the percentage by mass of all the component elements in sodium tetraoxosulfate 6. Na is 23, S is 32, O is 16. The second one is, what is the percentage by mass of iron 3 oxide? What is the percentage by mass of each element, please? Of each element in iron 3 oxide. So Fe2O3. So you do that. What is the percentage by mass of sulfur in aluminum tetraoxosulfate 6? What is the percentage by mass of sodium in sodium hydroxide? Summary. We have learned the following. Definition of formula mass. Don't forget I said the formula mass is the sum of the individual relative atomic masses of elements in a compound. We have learned how to calculate the formula mass, and also we have also learned how to calculate percentage composition by mass of each element in a compound. This will be your assignment, your take home. Calculate the percentage composition of each element in calcium triazocarbonate 4, CaCO3. Calculate the percentage composition of each element in sodium trioxocarbonate carbonate 4, this carbonate 4, Na2CO3. Calculate the percentage composition of each element in lead 2 trioxonitrate 5, DbNO3, bracket 2. From Mr. Henry Okorie. Goodbye.